Hello, today we're going to be talking about RREF, or Reduced Row Echelon Form. RREF helps you solve systems of equations using matrices. The rules of an RREF is that you can switch rows of a matrix. You could also multiply a row of a matrix by a constant and store it in that row. You could also multiply a row by a constant and add it to another row and store it in that row. All of these rules allow you to change a matrix to get you closer to your identity matrix. The order in which you change a matrix is this matrix sample, 1 being the first thing that you changed and 9 being the last. This is the identity matrix, or the final form. These numbers and these values are the final numbers that you want to get to. You want 1s in the diagonals and 0s in all the other spots. X, Y, and Z are your answer. Let's try some RREF with a 3x3 matrix as a system of equations. Here you can see we've already got a system of equations with a matrix to coordinate with that. And we need to get to our identity matrix, so we're going to do -2 times row 1 plus row 2 is equal to our new row 2, because we're going to need to get this 2 down to 0. So our new matrix is going to be 1, 2, 1, 6, 0, -5, -3, 1, 3, -4, -11, and -3. Now we're also going to need to get this value down to 0. So what we're going to do is -1 times row 1 plus row 3 is equal to our new row 3. And the new matrix is going to be 1, 2, 1, 6, 0, -5, -3, -11, 0, 1, -5, and -9. And so we're also going to need to get this value down to 1. So what we're going to do is divide the entire row 2 by -5, and we're going to get a new matrix equal to 1, 2, 1, 6, 0, 1, 3/5, and 11/5, 0, 1, -5, and -9. Our next step is going to be getting this value down to 0. So what we're going to do is do -1 times row 2 plus row 3 is equal to our new row 3. And so our new matrix is going to be 1, 2, 1, 6, 0, 1, 3/5, and 11/5, 0, 0, -28/5, and -56/5. Now, we're also going to need to get this value down to 0. So we're going to do row 3 over -28/5 is equal to our new row 3. So we're going to get 1, 2, 1 is equal to 6, 0, 1, 3/5, and 11/5, and 0, 0, 1. Oh, I said 0, I'm sorry. And 2. And we're going to also need to get this value down to 0. So we're going to do row 3 times negative 3/5 plus row 2 is going to be equal to our new row t, and we're going to get 1, 2, 1, 6, 0, 1, 0, 1, and 0, 0, 1, 2. As you can see, we're getting closer to our identity matrix. Sorry. And we're going to need to get this value down to 0, so we're going to do negative 1 times row 3 plus row 1 is equal to our new row 1. And we're going to get new matrix of 1, 2, 0, 0, 1, 0, 0, 0, 1, and 4, 1, 2. And we're going to need to do negative 2 times row 2 plus row 1 is equal to our new row 1, and we're going to get the final matrix of 1, 0, 0, 2, 0, 1, 0, 1, and 0, 0, 1, 2. Now, as you can see, 2, 1, 2 would be equal to our final x, y, and z values. So our final coordinates are going to be 2, 1, and 2.